Hello, my name is Tom de Saulles and I'm a building services engineer working at the Concrete Centre. And I'm going to talk to you today about heavyweight, high thermal mass concrete floors and how they can be used as part of a passive cooling strategy in buildings. And I'm going to run through the main system options, and I'll also show you some examples of buildings that use these systems. Now, everything I'm going to talk about is covered in this publication called Concrete Floor Solutions for Passive and Active Cooling. If you want a copy of that, you can download it from our website, and the address for that is www.concretecentre, that's all one word, .com. Now, the use of heavyweight concrete floors for cooling started to become popular back in the mid to late 90s when a series of owner-occupied, fairly prestigious headquarter buildings were constructed, and these all had exposed concrete soffits which are an integral part of the cooling strategy. Now, since then, the technique has started to find its way into more mainstream construction, including speculative offices. There's a few examples in this slide. And really the reason why it's growing in popularity is because, of course, it enhances the fabric energy efficiency, which in turn cuts the CO2 emissions quite significantly. And this graph, I think, makes the point quite well. And what it shows you is the emissions from a typical air-conditioned office, also for a good practice office with energy-efficient chillers and good solar shading, etc. And then finally, you can see on the graph the type of building that I'm talking about, which is the heavyweight high thermal mass office, which incorporates some form of passive or active cooling system. And as you can see, the emissions for that type of building are considerably lower. Now, going back a few years again, there was really only two options to choose from. You could go for a bespoke concrete floor made with in situ ready-mix concrete, and it might be coffered, profiled, like the image to the left of this slide. And that might also be combined with underfloor ventilation. This approach was very popular in the headquarter buildings I mentioned just now. The only alternative to that really was the Thermdeck system, which is an off-the-shelf solution that uses precast hollow core concrete slabs that are combined with a mechanical ventilation system. Now, these are both excellent options, still available today, but what's changed over the years is that we've had some new systems come onto the market, which you can see here. So I'm going to briefly run through these. But before I do that, just a few words on why it is that soffits are very good at providing cooling. And it's essentially because we lose about 60% of our body heat by radiation. And in order to be able to do that effectively, we need to be able to physically see another surface that is cooler than we are. And of course, the soffit is ideally placed to do that. It's never very far away. Distance is also important. The closer the surface is, the better. It doesn't tend to get covered up like floors and walls do. And it has, of course, a very large surface area, which helps. And if it's made of concrete, it has a high thermal capacity, so that means it can absorb an awful lot of heat during the day whilst maintaining a pretty stable surface temperature. So it's always a lot cooler than we are. So that's why we tend to use heavyweight soffits for cooling. Now, the simplest option is just to have a plain, flat concrete soffit. Could be precast, could be in situ, doesn't really matter. And if that's in a building that's naturally ventilated, so from windows that can be opened, importantly at night, because of course we need to get rid of excess heat that's built up in the fabric during the day, then in that building we'll probably get around 15 to 20 watts per metre squared of cooling directly from the soffit. Now, that's not a huge amount, but it's enough to ensure that you won't have an overheating problem in buildings with low internal heat gains and a low occupant density. Now, I should just point out that on top of that 15 to 20 watts, you can also get up to 40 watts of cooling from the natural ventilation, depending, of course, on the weather conditions. Now, I'll show you an example of a building that uses this approach. This is the Cambridge Federation of Women's Institutes building, which is actually a converted farm building, and and they've replaced the roof with precast slabs to form a simple monopitch roof that's insulated on the outside so that the soffit's exposed on the inside, which is of course very important for the thermal mass. It's well ventilated, lots of openings on the front, and it's got ventilation grills on the back wall to provide secure nighttime ventilation. So a very simple design, but very effective, and the occupants are extremely happy with the performance of this building. Here's another example. This is the National Trust headquarters in Swindon. Slightly more sophisticated in as much as it's got a mechanical ventilation system, but primarily it relies on natural ventilation during the summer. And here you can see a view of the soffit in one of the office areas. Again, just ordinary precast concrete planks, painted with white emulsion, very simple finish. But I think the most interesting feature of this building is actually the atrium, where they've incorporated precast panels, concrete panels, in the roof structure, and they're simply there to provide additional thermal mass, so they're not structural in any way. Now, another building that uses a similar approach is the Woodland Trust headquarters. Same architect, Field and Clay Bradley, and unsurprisingly this is a timber building. It's actually made with cross-laminated timber, so it's a fairly lightweight construction, and in order to ensure that it doesn't overheat during hot conditions, they've incorporated some precast concrete panels on the soffit. They're simply bolted to the cross-laminated timber soffit, and these are painted white, which you can see here in this photo. Right, the next system is where you have a coffered slab with underfloor ventilation. Now, of course, coffers are used to reduce the weight of the floor so that you can increase the span, but they also have the added benefit of increasing the surface area, so you've got more area to get heat in and out of the soffit, which in turn improves the cooling performance. Now, if you combine that with underfloor ventilation, so you've got air in contact with the top of the slab as well, you've now effectively doubled the surface area through which you can get heat in and out of the concrete slab. So really you're making maximum use of the thermal mass, and that's why you can get up to 35 watts per metre squared of cooling with this system. And here's an example of a building that uses this technique. This is the Canon headquarters in Surrey, and I could have also shown you the Toyota headquarters in the UK, or the PowerGen building, which was actually the first to use this approach. All very similar. They're all built over 3 floors with a large central atrium. They have perimeter windows that can be opened, and importantly they have an open balcony arrangement so that air from those windows can travel freely across the soffit and into the atrium, and as it warms up, it becomes more buoyant, it rises up and leaves the building at high level through the openings you can see in this slide. And incidentally, these openings quite often also double up as part of the smoke extract system, so it's quite an efficient design. Now, as I said, they've all got mechanical ventilation as well, underfloor mechanical ventilation. That tends to get used mostly in the heating season, when you want to keep the windows shut and keep your ventilation to a minimum. But it can also be used during the summer when you need some additional ventilation, perhaps on a hot summer night when conditions are quite still and you need to get some air moving through the building. The next system is the Thermdeck system, which is very popular in the UK. It's been used in quite a large number of buildings. It's been around for a long time, and it essentially uses precast hollow core slabs that are linked to a mechanical ventilation system. So you've got air passing through those cores, and I'll show you how that works in this slide. So here we've got a cutaway of one of the slabs, and what they do is to drill out the webs, the concrete webs between adjacent cores, so that air can get from one core to the other, and then it travels up and down the cores in a serpentine arrangement before it enters the occupied space through a diffuser on the underside of the soffit. So you've got very good contact between the air and the concrete, so very good heat transfer, and that's why you can get up to 40 watts per metre squared of cooling. Now, it also works really well in the heating season, because what you can do is at the end of the day you can recirculate the warm air in the building through the slab, and the concrete picks up that heat, hangs onto it until the next day, and when the occupants come back into the building and the ventilation is switched on, so you've got cold fresh air coming into the building, the heat in the soffit warms that fresh air and of course reduces the load on the heating system. Now here's an example of a building that uses the Thermdeck system. As I said earlier, there's a very large number of buildings in the UK that use Thermdeck. This one is the Jubilee Library down in Brighton. Very heavyweight construction. Here you can see the south facade, which is highly glazed, so very good daylighting, but also very good for some passive solar gains during the heating season. And I'll just show you one of the perimeter reading rooms, which uses the Thermdeck system. Pretty unremarkable, just a plain, flat concrete soffit painted with white emulsion. You can see in the shot one of the supply diffusers, and we've got suspended light fittings with acoustic wings. That's a very standard feature in all of these buildings, because of course you've got a hard concrete soffit and you need to control the reflected sound of that soffit, and acoustic wings work extremely well. The next system is called Concrete Cool. This is a German system, been used for a number of years in Germany, and to date I think it's been used in around 250,000 square metres of office space. Very similar to Thermdeck in the way it works. The key difference is that this can be used with in situ concrete slabs. If you remember, the Thermdeck system uses precast slabs. And what you do is to embed these circular aluminium air ducts in the slab. These come in two sizes, 60 and 80 millimetre, and they're made by a German air conditioning company called Coffered. And I have a sample here to show you, and it has a lot of internal fins to maximise the surface area, so you get really good heat transfer between the air and the aluminium duct, and in turn the concrete. And that's why you can get up to 65 watts per metre squared of cooling with this system. Now, the only building that this has been used in so far in the UK is the 4 West building at Bath University, which is 6 floors of office space and teaching areas. And when it was completed back in 2010, it got a BREEAM Excellent Award. And I'll show you one of the floor slabs being constructed. And you can see the orange formwork with the reinforcing mesh placed on top of that, and then we've got the Coffered aluminium air ducts. These incidentally are all pre-cut at the factory, and when they're delivered to site, all you've got to do is just assemble them, which is a very easy job. There's still some reinforcing to go on top of the aluminium ducts. So the ducts themselves are actually in the centre of the slab, so they're not in any areas of tension or compression, so they're not affecting the slab structurally in any way at all. The next system I want to show you uses water rather than air to regulate the soffit temperature, and that has a number of advantages, not least of which is that you can control the soffit temperature 24 hours a day if you need to. So you're not reliant on nighttime cooling to regulate the temperature, which is of course subject to the vagaries of the weather. Now, quite often with this system, the water is supplied from a borehole going down into an aquifer, and that brings water up at around 13 or 14 degrees, which is ideal. That'll give you the maximum cooling output possible from your soffit. You don't actually want water at a lower temperature than that, because you run the risk of getting condensation forming on the soffit. And another thing you can do with the system is to connect it to a heat pump, so you can boost the temperature of that water coming out of the aquifer and use it to heat the slab during the heating season and provide some radiant heating. Now, the slide you can see at the moment shows a composite lattice girder soffit slab, which gives quite a high quality finish to the soffit. And I'm going to show you an example of a building that uses this approach. This is the Manchester Metropolitan University Business School, a very large project completed in 2011. And here you can see one of the floor units being craned into position. They've actually used rectangular polystyrene void formers. And this is what the units look like once they're craned into position. And if you look to the right of this slide, you can see, hopefully, that the columns are reflected in the soffit, which just shows you how good the surface finish is. And on this particular project, they achieved it using a blend of 75% white cement and 25% ordinary Portland cement. And although that increased the cost of the precast units, they actually found that it saved money overall because, of course, they didn't have to paint the soffits. And this shows you the finished result. And just one thing to point out in this slide is the way they've used the rebate between precast floor units to conceal the wiring for the lighting, which is quite a neat touch. The next system I want to show you is very similar in terms of cooling output, which is around 65 watts per metre squared. The only difference is that now we've got a precast hollow core slab with embedded pipework instead of a lattice girder slab. It's a slightly cheaper option, and it has a slightly more utilitarian surface finish, but once it's been painted, it's absolutely fine. Now, the cover over the pipework is about 60 millimetres, so it's very well protected. But just to be sure there's no damage on site, what tends to happen is that the contractors are issued with shanked drill bits, which ensure that if they're drilling into the soffit to mount something, the drill bit cannot reach the pipework. Now, with both systems, the pipework is pressure tested at the precast factory, so once it's delivered to site, it just has to be connected up to a distribution manifold and it's ready to go. And this building, Vanguard House, which is a research facility in Cheshire, uses the hollow core option. This got a BREEAM excellent rating when it was completed in 2011, and here you can see the hollow core units in position. One thing just to mention about this option is that the hollow core units have top strand reinforcing, which ensures that the soffit is absolutely flat. Now, typically hollow core slabs don't have top strand reinforcing, and as a consequence of that, sometimes you can see a slight camber when you look up at the soffit, but that's not the case here. Now, if you look to the left of the photo, you can see all of the pipework sticking out of the soffit, and this is polybutylene or PEX pipework, and it's ready to be connected up to the manifold, distribution manifold. That'll be concealed in a bulkhead along with the steel beam. And this shows you the finished result after it's been painted with white emulsion. Pretty good surface finish. And once again, you can see the use of acoustic wings to control the reflected sound. And the only other thing really to say about this building is that it also uses nighttime ventilation to cool the soffit down, and they've done that to maximise the fabric energy efficiency of the building. The final system I want to show you is where you use a combination of chilled beams with an exposed concrete soffit. Now, the two work very well together because the output from the beams is nearly all convective, whereas the cooling output from the soffit is mostly radiant. And you need a combination of the two to achieve comfortable conditions. Now, the beam itself can give you 160 watts per metre squared or more of cooling, which is very high. The soffit will give you around 20 to 25 watts per metre squared of cooling. And this approach is popular in new build, but it's also popular in refurbishment projects, particularly where you've got concrete frame office buildings from the 1950s and 1960s. And these buildings tend to have fairly poor slab-to-slab heights by modern standards. And if you want to put in a raised floor, which you invariably do for all your cabling, then that just compounds the problem. But what you can do is to strip out the full ceiling, and make good any blemishes in the concrete, give it a coat of white emulsion, and put in some low profile multi-service chilled beams, so it'll provide the cooling, the lighting and other services such as fire alarms and smoke detectors. And here's an example of a building that uses this approach. It's Conquest House in London, which is an old 1950s concrete frame building, now occupied by an international business school. And as I described, they've essentially stripped out the full ceilings, painted the concrete with white emulsion. It was a fairly good surface finish, so that was an acceptable thing to do. Put in some chill beams and also put in a raised floor. And I think you'll agree it's a pretty good standard of finish. Right, that's the end of my talk. As I mentioned at the beginning, everything I've covered is included in this publication, and you can download that from our website, which is www.concretecentre.com. And in it you'll find this graph which summarises all of the systems I've spoken about in terms of their cooling output, and has also got a few additional systems in there. And it's just quite a good way of comparing performance. Finally, also, if you go to our website, specifically the publications area, you can find the publication on the right called Thermal Mass Explained. And if you're not familiar with thermal mass, that'll give you a pretty good introduction to what it is and how it can be used. Thank you.